SOA XMP practice question number 45. A manufacturing plant has 5 machines. Each year, each machine independently has a 90% probability of not breaking down. If a machine breaks down 1 or more times, the number of breakdowns is modeled by a geometric distribution with a mean of 1.25. The numbers of breakdowns for different machines are mutually independent. Each breakdown incurs a repair cost of 10,000. Calculate the probability that the plant's total repair costs in a year are less than 23,000. Let's take a look at the solution. Let X be the number of machines breakdown. X follows a binomial distribution. There are altogether 5 machines, so N equals 5. And the probability of not breaking down is 90%. So the probability of the machines breaking down is 0.1. And we have the PMF of X. And if a machine breaks down, let N be the number of times the machine breaks down, and N follows a geometric distribution with a mean of 1.25. So the parameter of the distribution is 1 over the mean, which is 4 over 5. And we have the PMF of N, which is 1 over 5 to the power N minus 1 times 4 over 5, where N ranges from 1, 2, 3, up to infinity. We need to calculate the probability that the repair costs are less than 23,000. And each breakdown incurs a cost of 10,000. That is, repair cost less than 23,000. There can only be a maximum of 2 breakdowns. To satisfy this event, the maximum number of breakdowns is 2. We have 3 different cases. The first one, no machine breaks down in a year. The second case, only 1 machine breaks down, and this machine breaks down 1 time or 2 times. The third case, exactly 2 machines break down, and each machine breaks down exactly once. Let's compute the corresponding probability. No machine breaks down, that is the probability X equals 0. Substitute 0 for X into the PMF of X. Then we get the probability 0.59049. The second case, 1 machine breaks down, that is the probability that X equals 1. And the number of breakdown is either 1 or 2 times. So we have the probability X equals 1, and then times the probability that N equals 1 or N equals 2. The probability for N equals 1 and N equals 2 make use of the PMF of N. The probability that N equals 1 is 4 over 5. And the probability that N equals 2, substitute N equals 2 into the PMF of N, we get 4 over 25. So the probability that exactly 1 machine breaks down and this machine breaks down 1 or 2 times equals to this expression. The probability that X equals 1 times the probability that N equals 1 and N equals 2. We get 0.314928. And then the third case, exactly 2 machines breaks down, X equals 2, and each machine breaks down only once. So the first machine, N1, equals 1, and then the second machine with subscript 2 with N2 equals 1. The probability that X equals 2, substitute 2 for X in the PMF of X, and then multiply the probability that N1 equals 1 and N2 equals 1. Each of this probability equals 4 over 5. Multiply them together. we get the probability equals 0.046656. And the desired probability, we add up these three probabilities, and we get the final answer, 0.9521.